Again, welcome to Database Management System. In these lectures, we're going to discuss about relationships within the relational database. So we're going to discuss about different types of relationships within relational database system. So our main objective is to identify the appropriate entities and then the relationships among the entities in a relational database model. Also describe how data redundancy is handled in relational database model. Also explain the purpose of indexing in relational database. So relationships within relational database, we have three major relationships. And the first one is one-to-many, which is known for relational databases. Then we have one-to-one, which is one entity can be related to one other than one entity or the vice versa. Then we have many-to-many. Normally, many-to-many, when we are designing a database and we have a relationship many-to-many, we try to break it down or decompose it to one-to-many by having one more entity or one or two more entity and reduce it to one-to-many. So the most common relationships we will see among entities in the relational database is one-to-many. And normally the relationships can be derived from the business rules of the organization. Let me give one example here. Let's say we have a school, an institution, educational institution, and the rule said a semester runs only 5 weeks or a section runs for 5 weeks. So one student can take only one class. So this means I can have one-to-one relationship between student and class. One student takes only one class. Now, let's say we have another educational institution. Their session runs for 12 weeks or 16 weeks, and the student can take up to 4 classes. So here we are going to have one-to-many. One student can take many classes. It can take up to 4 classes. So we can see that again, relationship between entities, normally we identify it or get it from the business rule of the organization. And one more time, we have only these 3 main relationships types in relational database system. One-to-many, one-to-one, many-to-many. So one-to-many example again can be one student takes many classes. One-to-one, one customer buy one product, or one customer can buy many products. Many-to-many, many students can take many classes. So many-to-many is implemented by creating the new entity in one-to-many. As we said earlier, anytime we have many-to-many, our goal is to reduce it to one-to-many by having more entity, at least one more entity. So here we say we implement it by creating a new entity in one-to-many relationship with the original entities. A composite entities, that is bridge or associative entity, helps avoid problem inherent to many relationships, including the primary case of tables to be linked. And we may discuss more about what is associative and bridge entity. Also, we have the weak entity when we start to discuss about case normalization. So this is one-to-many, so that's the symbol we use. Here we are saying that only one professor can chair one department. So this is a relationship between professor and a department. One professor chairs one department. Then here we are trying to change many-to-many to one-to-many relationships. So this is an example we're trying to say. So here we say, many students has many classes. We can include a new entity. In this case, we name it enroll. Then we can make it one-to-many. So here we can say one enrollment registers one student, or one student registers one or many enroll. And also One class shows in one or many enrollments. This is an expanded ER model. So we can see that we have, again, 4 entities. There's a relationship between course and the class. So we can say one course has one or many classes. And the relationship here is many. The 2 dash line is 1. Also, we can say one class enrollment, many enrollment shows in one class. Or one student registers many enrollments. So we come back to data redundancy. The earlier time we say the goal of data modeling and also designing a database system before we implement it. One of the major goals is to reduce the data redundancy. And that also leads us to include the primary key fields, secondary key fields. The main goal of normalization, the key fields, is again reducing the redundancy, data redundancy. So here we say a relational database facilitates control of data redundancy through the use of foreign keys. Foreign key is a key that is primary in another entity. So this makes it possible to create a relationship between those two entities. So it will be common attributes that are shared by tables. So we can have a student ID is a primary key field in student table, but student ID is a foreign key in a course table. And when I create a relationship between student and course, I will use the primary key student ID in the student table, connect to the primary and the course ID the student ID in the course table. So we create a two relationship. So now in this case, the student ID becomes the primary key in the student table, but it's a secondary key or foreign key in a course table. So here we say relational database facilitates control of data redundancy through use of foreign keys. To be controlled, except the following circumstances, sometimes data redundancy must be increased to make the database serve a crucial information purposes. Also, sometimes data redundancy exists to preserve the historical accuracy of data. So this is a relational diagram for the invoice system. We have one customer. We can see the symbol here changes. This symbol normally comes from Microsoft Access. So we can see that the course ID is a primary key field in the customer table, which is the course code. We also have the course code in the invoice table. So that means course code in invoice table is the foreign key. So we can see that the relationship will be, since course code is a primary key field, we cannot have more than one unique value. So the relationship, they have to be one to many. Secondary key is not a key in that table. So we can refer to course ID. If a student have 10 invoices, then we may have a course code 10 times in the invoice table. The same thing, we have the invoice number. It's a primary key in the invoice table, but it's a foreign key in the line table. So we have invoice number, one invoice number to many line number. Many invoice number. Then we have product code, one product code to many product code in the line table. So we also have what we call the index file organization. Here, the storage of records sequentially or non-sequentially with an index that allows software to locate individual records. And an index is more or less like a table or view So index a table or other data structure used to determine in a file the location of records that satisfies some condition. So primary keys are the automatically indexed, and other fields or combination of fields can also be indexed. These are called again the secondary keys. So orderly arrangement to logically access rows in a table. Index key is the index's reference point that leads to data location identified by the key. The unique index is the index key can have only one pointer value associated with it. So each index is associated with only, again, one table. So the index key can have multiple attributes. This is the course relationship, relational database rules. So we have the rule name information. Here we say informations, all information in a relational database must be logically represented as column values in rows within tables. And the guaranteed access means every value in a table is guaranteed to be accessible through the combination of table name, primary key value, and column. Then systematic treatment of nulls. Here we say nulls must be represented and treated as systematical way, independent of data type. Then dynamic online catalog based on the relational model. Here we say the metadata must be stored and managed as ordinary data, that is, in tables within the database. Such data must be available to authorized users using standard database relational language. We also have the physical data independence, application program, again, and ad hoc facility are logically unaffected when physical access method or storage structures are changed. Then the logical data dependency, application program and ad hoc facilities are logically unaffected when the changes are made to the table structure that preserve the original table. Integrity dependence, again here, all relational integrity constraints must be definable in the relational language and stored in the system catalog. We also have the distribution independence. The end users and application programs are unaware of. So in summary here, we say tables are the basic building block of relational database. As we said in our first lectures, relational database model. Tables are like the building block of a database system. And a table must have a unique field, which will be the primary key field. So keys are central to the use of relational tables. Each table row must have a primary key. So again, to eliminate the unique redundancy, the primary key will eliminate redundancy. So we have a unique field. So again, this will be the conclusion of our lectures. In this lecture, again, our main goal was to cover the three types of relationships in a relational database system, which is one-to-one, one-to-many, and many-to-many. Normally, we say that anytime we have many-to-many, we do our best to include one more entity and then convert it to one-to-many relationship. So again, wish everybody the best and see you in the next lectures.